Hey guys, this is Steven from LegitTechTutorials and welcome back to my product development series. We are back working on the RC brushed Wi-Fi receiver. So you use your phone and to start out with an ESP8266-01 to control remotely via a cell phone and be able to fly an RC plane. We're going to start out with 2-channel control. And this is continuing on from my last video, so we are setting up for a event to premiere the idea at an event called Flight Fest in Vallejo. It's coming up on the 27th, and that is Thursday until Sunday. I am signed up as a volunteer there. They have a confirmed in between 500 and 600, more towards 600 pilots right now as of a few weeks ago, so I don't know what the current count is. And also I'm signed up as a volunteer, and they have confirmed 90 to 100 volunteers as of 1 or 2 weeks ago. So it's going to be a very large event, and I'm looking forward to getting some feedback as far as the design of this guy. So some people that are new into the hobby, well, probably not likely anybody there be new into the hobby unless they're spectators, but also, you know, kids being able to fly these around, and these will be especially good for if they want to do the around the pole type stuff. Like my flyline planes I like to build. Anyways, so I have purchased some parts locally that I was talking about in my last build. I probably should have done more research before I bought it, but hey, I'm gonna buy it and try it because, like I was telling you guys, if you guys want to come, if you guys are at this video to see an expert build electronics, this is the wrong video for you. I'm a mechanical engineer. I'm not an electrical engineer or electric hobbyist. I mean, I do electronics, but I don't know, you know, the different transistors and stuff. Usually I just buy modules that do certain things and then link the modules together. So this is the first time that I'm working with the nitty-gritty, you know, the components themselves. So I went to a place locally in Santa Clara called Anchor Electronics, and I purchased a few components after talking to somebody there and giving me some information. So what I have inside of this bag here is I have a whole bunch of different components and also some stuff from Aeromicro for the trip. I have some MCX plugs for 1-cell batteries, and that's also what's I'm going to use on the ESP is 1-cell Venoms or E-Flights. And altogether they cost me $8.25. Wait, no, let's put them around like this. They cost me $5.41 for all these electronics that I'm about to tell you. But unfortunately on this little paper it doesn't show all the electronics I bought. Luckily I have the catalog that I'm pretty sure I can find the electronics that I bought. So I bought some, as we were going over, I bought some transistors. So I bought what they call, I was originally going to buy a MOSFET, but I ended up buying what they call, because the issue with the MOSFET is that from what I learned while I was there is you have to have like a pinch voltage, which means that there's a certain voltage that you have to put on the MOSFET in order. Basically the MOSFET is like a Venturi valve on a carburetor where it has like this throat, right? And then your signal is basically constricts the throat, closes the throat up, and it doesn't allow anything in there. So you have to have a certain voltage in order to close that throat off entirely. Otherwise, it'll just let the voltage right through, and you can't have that in RC, right? You can't have a motor never turn off. You know, that's dangerous, and it'll, you know, break your motor. So what you need is what they call a logic level MOSFET, which means that you have a logic level of 3.3 volt in this case for the ESP8266, or 5 volt for a Arduino. But if you get a 3.3 and you get an Arduino that runs on 5 volt, then obviously it's going to work. So you need a logic level cutoff pinch voltage that will be able to turn it all the way off. because if it doesn't turn all the way off and it leaks, it's just going to keep turning that motor, and then you're going to have problems. So I believe that they didn't have any. I looked online at a few lists, and I believe, even though they have just 2 front and back pages of transistors, none of them were logic level MOSFETs. So the other options I had were a FET and power and a standard power transistor, or a general purpose transistor. So general purpose, FET, power transistor, or some of the other ones. What I've seen now, a lot of people are doing like the TIP 120. It's supposed to be a pretty good one. It's a Darlington style, and still I don't really know what much of the. I know what all the styles are. I don't know what they do exactly. I'm learning it as I go along, so I'll teach you guys what I learn as well. So the type that I got was an MJE 210, which is a power transistor PNP, and it has a PD, or power dissipation, of 15 watts, and a voltage of 25 volt and an amperage IC of 5 amp. And it is a package type of TO126, which is one of the smaller, lighter packages. So I have 3 of those here. They're decently small, and as you heard, they could do a maximum power dissipation of 15 watts. So that's definitely fine for any sort of brushed little can motor, even up to an 8.5 millimeter motor that pulls 1.5 amp. We're still double spec, right? Well, 1.5 amp or 3 times spec, because that's 5 watts of dissipation. And we're talking, because wattage is equal to voltage times current, and so if you have 1.5 volts, 1.5 amps, which is usually what they pull max, and then you have a volt of 1 cell, which is 4.2 for a standard LiPo, or 4.35 for HILV, a high LiPo, high voltage. You're talking 4.5. You're talking 4 plus 2, that's 6, plus a little bit more, so it's like 6.5, 7 watts. So we're half, right? But most of these are going to be, I'm going to try to do it as light as possible. Also, another thing to note is that these, all these electronics together, the entire control system is going to weigh, not including the servo, is going to weigh 6 grams, which is pretty heavy. So I can't wait to get this guy finalized a little more to do an SMD version, and the SMD surface mount device will definitely be a lot lighter. Where's the rest of it? Where's those? Where's the diodes? These are already. Oh, they're right here. Then I got some diodes, and I'll show you what the diodes are used for. Actually, I'll show you guys why I bought diodes here in a second. And then I bought some 3.3 volts, some LT 11171. What? It's supposed to be. Let me look here at the catalog. This is a very popular 3. Is it right here? Yeah. No. Here it is. LT 1117, 1117, and that is a 3.3 volt regulator, and it can handle 1 amp. The other one I was looking at was the where is it? Micro power, but that only does 100 milliamp, and there's another one on here. Yeah, so 100 milliamp. It's a TO92. It's a really small package. The one I got was a TO220, which is the larger package, the same size, similar package size of the. Actually, it's the biggest. 220 is a very large package size. So it's very big and it's very heavy. And also it has a big IC sink on it, even though it only does 1 volt regulation. And we're talking about going from 4 volts to 3.3 volts. So I mean, there's not much of a drop there. It shouldn't be that big. So those are my 3.3 volt regulators, and then I have some capacitors and diodes. And I'll show you guys what we're going to be doing with that. So here we're in what's called 123D circuits from Autodesk. It is the one that I'm most familiar with. I have not taken a class at Tech Shop about Eagle yet, or watching YouTube videos on it, so that would be next. But this guy's also pretty good at even designing some simple stuff like PCBs off some of the stuff that you just lay out a prototype on the breadboard. So this is how I'm going to show you guys visually what circuit I'm going to make, and then it will give us something that we could print out of the layout, the schematic, so that I could assemble the schematic. And yeah, so we're going to lay everything out in here, and this also has, pretty cool, you could also program in here and run some simulations. You'll see down here that they have a beta of the ESP8266, and this is the 01 size. And it has the same everything. So, alright, so what we're going to copy for this schematic is the Robo Remo, which is the project that we're going to use for our phone to run the receiver. And you see this is built for a Wi-Fi RC car. And the reason why I like this is it has both a electric speed controller, or an ESC, and also a servo, which is what we're doing for a 2-channel. We want ESC for the motor, for the brush motor, and a servo. And this could either be a in this case, I think he's using a pre-built I think he's using a pre-built ESC, and it could if you're using a pre-built ESC, you could either have it brushed or brushless because it's already got all the electronics in it. However, for us, we're just using a single transistor. So what we're going to change here is we're going to use this guy's same pinout, and again, this is using the ESP8266 01. Maybe I'll even show you the video if it's short enough. But basically what we're going to do is we're going to combine this schematic, cut off this part, and then combine this schematic, which here's similar. I believe that's a power MOSFET. That one right there. I'll have to look it up again, but I think that's a MOSFET IRL. I saw that one, and I tried to find it, but Anchor Electronics didn't have it. So yeah, it's a MOSFET IRL. Yeah, they don't even have IRLs on here, but I believe it's a MOSFET. So right here on Adafruit, right here, build a simple motor driver. Here they're using, this is a PN2222 transistor, which is a general purpose transistor, and it is the TO92 package size, which is the really small little half moon ones. I actually believe I have one in the other room, but those guys, the reason why I didn't buy one of those, where is it, PN222, here it's 4 2s and an A, so it's not exactly that. General purpose NPN with a maximum dissipation of 600 megawatts. So that's why it's a little on the low side. It'll work for a smaller motor, but the power that it could dissipate for melting, basically melting itself down, is pretty low for any application. For our application, we're going to use this power transistor that, and of course I'm not exactly sure if that's the best use of that type of a power transistor. I'm pretty sure I probably should have used a logic level MOSFET, but we could order one later, unsolder that one, and then use that. It's not a big deal. Next one they have is they have a diode, so that's why I bought diodes, but they're using the, let me tell you why I'm not using that one. Diodes D, page 15. So they're using the 1N401, which is a very popular diode. I'll tell you why right now I'm using it. So that's a rectifier diode, but its maximum amperage is 1 amp. So that guy will blow up if we were using that. If we were using that one, pretty much. So the ones I bought, oh man, can't remember. It was down here somewhere. I think it's the 1N5401, I believe. Yeah, it says it right here. 1N from DN. 1N5401. 1N5401 rectifier diode, 3 amp, 100 volt. So that can take a maximum of 3 amps. So we're double over spec on that. Should be fine. And also we have a whole bunch of air flowing over it because the plane's flying. And then we have some resistors. I have some in the other room, a whole bunch. And then they're using a half-size breadboard, Arduino, some jumper cables, blah blah. Okay, so basically this is the schematic that we're going to do. This is not this. Remember, they had a different schematic. They had an actual schematic. Oh, here we go. So here's the schematic here. So here's the Arduino, and they're basically coming out of D3, coming into the transistor, letting the power go through. In this case, it's connecting to ground. I believe that particular transistor would be backwards in our case. So theirs is a PN2. So it's an NPN. So it's on the negative side, and then ours is a PNP. So ours should probably be on the positive side. So it should be on this side with the 5 volts coming in, or in this case our battery. So this would be our battery coming in. I believe our transistor would need to be over here, and it lets it come in and come through. And then here's our diode. Basically what the diode's for is it's basically a protection. So what you do is you put this protection on the battery, on the transistor side, to not allow, basically what happens when you have a motor, right? Every single time you turn it on, there is a back force, right? Which is basically it trying to, because when you're giving it power, it's also generating power, and it's called EMF, which is basically the coils are generating a magnetic force when you're even when you're driving it. And then especially when you pull your power all the way off on your plane, and you don't have a brake system, you're not using a brushless controller, so your motor doesn't stop. What happens is it turns into a turbine. It'll start to generate electricity and feed it back through your power line. And then so you don't want it to feed back through your power line and destroy your transistor. So what you do is you put a diode in there to only let the power go to the motor and not back to the transistor. So diodes only allow current to go one way as long as you're not past the breakdown voltage, which basically destroys the diode and causes it to leak current, which we're not at that point. Like I said, for ours it's like 100 volts, and we're only talking about 4 volts here. Okay, so let's go ahead and start laying it out. So again, we're just going to be combining these two schematics. And here's our ESP8266, and then we're going to put in a transistor. And we're talking about a standard BJT, and then these are other MOSFET, PMOSFET, NMOSFET, PMOSFET, temperature sensors, why do I have 2 PMOSFETs? Oh, wait. Oh, PMOS, and then this is a PMOSFET. So we're doing a standard BJT, and ours is also another thing we could simulate on here, so this will also tell me if I'm doing anything wrong, because I still kind of not really a good sign, but I don't really have any clue of what I'm doing as of right now. But I'll learn, of course, before I put it together. So after this video, do more research and stuff. This is a PNP. So we're talking about a PNP transistor, and this is the name. I'm going to call this the name of the actual transistor, MJE 210. And then we'll just put it right there for right now. The next one is the diode, which is back this way. I'm just going to drop it in there. Oh yeah, I forgot, I have one more component, which is the capacitors. I'll tell you guys those in a second. No. Go back to the front. Diode 15. These are the 1N5401. So this is diode. No, it's not a Zener diode. This is 1N5401. Okay. And then I have a capacitor, which I didn't mention. So the capacitor, capacitor 1213, and those are referenced to the basically what they could no, these ones. Where is it? Here it is. So these are basically with reference to these are the radial kind, not the pancake kind, not the disc kind. These are the cylinders. These are with reference to the microfarad number, and also the voltage that they could take without blowing up. So what you need from this guy, this is just some buffering stuff here. These two are just to, you know, make sure you get good signal and stuff. You have to have two per. So one is, they're 47 mu, which is microfarad, right? This is supposed to be a mu logo. So that's microfarad. 47, and then you pick your voltage. In this case, I did the one with I believe it was the one with 6.3 volts, which I probably should have went higher than that, but whatever. So 47 microfarad, 6.3 volt, I think, or it might have went 10 volt. I can't remember. I don't know if it even says on there. Yeah, 6.3 volt. Probably should have done 10 volt. That might have been an oopsies. But those are 10 cents a piece, so it doesn't really matter. Capacitor, voltage rating 6.3 volt, and 47 microfarad. And this is, yeah, this is just one, and then polarized capacitor 2, and this is 2, and this is also 47 microfarad and 6.3 volt. Alright, and those are, oh yeah, and then we have the cool stuff. We have a motor, and we have a small DC motor. Doesn't really matter. Oh, it looks like a propeller, so it's kind of cool. Then we, just got a stepper driver, H bridge. We don't have an H bridge. It's interesting you put motor and then these things come up. So obviously I probably should have went with a MOSFET. But we're going to do power transistor. It might not switch very quickly, but or also it might even be the wrong one, but I'll definitely figure out on it after this video if it's the right one or not. If it's the wrong one, we're just going to switch out which one we use there. But if they could use the that to power that small one, you should be able to power the other one with this. Next thing that we need is the servo, micro servo, little micro servo. Ours is
actually looks kind of like that instead of this one, but whatever. So this is, I'm just going to call this a servo. And this is, oh, I didn't know you were rotating this. This guy is the prop. Okay, so let's go ahead and lay this out. So what I'm going to do is just lay these guys on here. It's negative, that's positive. These are polarized, so you have to put them in a certain way. There's a diode, and there's the motor. Oh yeah, and then one last piece, we have our battery. So this is 1.5 times 2, so you're going to need what? 3. So this is around 1 LiPo, pretty much. Or we could do a power supply, but that's pretty much around 1 LiPo. So these are 1.5, 1.5, 1.5, all in series. I believe these are in series. Yeah, it should be in series. So that's a total of 1.53, 4.5, which is a little bit higher than a LIHV, but that's fine. Okay. So let's go ahead and wire this bad boy up. So we're going to go from positive here to the positive rail, and let's make this red. Let's go from negative to the negative rail, and it's going to be black. Oops, black, and then TX ground. And then let's go ahead and ground our ESP. Black. Oops. Black. And then where is VCC? VCC. And then this is red. Okay. And then basically this guy goes also to power. Red. And ground. Black. And then we'll figure out how this guy's gonna wire. Okay, so we got that, and now we have these pieces here. So let's go ahead and go off this schematic here. So let's go ahead and hit Control plus a few times. All right, so oh yeah, I forgot one thing. We forgot the voltage regulator. And the funny thing is, actually, this guy actually has that particular voltage, 3.3. It actually has that particular. Oh no, it is a different. I thought it was that. I thought it was the exact same one. It's a different one. Whatever. So there's the voltage regulator. So that's the LT111, 3 ones and a 7. So let's call this LT. LT1117. Alright. Okay, so basically what we have is we have the 5 volts out, which is basically our battery. Comes in here, and then we have a capacitor that is going, a few things attaching to the capacitor, it looks like. So let's take a look here. So we have, okay, so let's do the 5 volt to the in first. So 5 volt to the in line, 5 volt in, and let's just say this is red because it's coming off the 5 volt. Then we have going into the in, and then off of the in we have the capacitor attached. It's the only thing that's attaching to the positive side. So the positive side of one of these ooh, it should definitely not be there. It should be right here. Also attaches to the in. And then any sort of hookup lines I'm going to make green. And then any data lines will be a different color. So also attached to the in, and then the out has a few things attached to it. The ground's attached to the out. So the ground is attached to the out. And then a few other things are attached. So the out is going to VCC. Out is going to VCC. Wait, why did I do that? This definitely doesn't do that. Out goes to VCC. This is red. And then also, that one also goes to channel PD, which is the out. Goes to channel PD. Let me make that green. Okay. These don't go nothing. Then there's the 2K resistor, which I should have also put. We'll put that in there in a second. Then this guy, don't worry about that for right now. Okay. Also, PS4 attaches to the out also attaches to a capacitor. The other one, the positive lead capacitor. Attaches to the positive lead of the capacitor. And the negative lead attaches back to the negative side of this capacitor. Negative attaches to the negative side. And this attaches to the negative side of the capacitor. And the ground goes here, which also attaches to the ground of the battery. So the ground of this guy, the ground of the first one also attaches to ground. So this one also attaches to ground. And then this is going to be a black wire. Black. Okay. Boom, 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 boom. So the PS6 attaches to some resistors, and it goes to here, and then this goes to the capacitor. So PS6 goes to the signal in, the signal side, which I believe should be the, I think it's the base. Yeah, I'm looking it up. Yeah, so I know it's reversed to the NPN. So here's the E, the collector, and here's the wait, do I have a PNP or an NPN? Yes. Huh. Whatever. We'll just set it up with how this is right now. So This is basically, this guy goes into this piece here. So it should show us when we go into the circuit mode, and we'll see the transistor just sitting there. Oh, here it goes. Okay, so you can reorganize this stuff. I was wondering if you do that. This is battery over here. This guy up over here somewhere. Okay, so we'll reorganize this so everything looks nice and neat. Or maybe even set up like a plane to where it looks kind of like the plane. Yeah, we're at 35 minutes in, so let's just go ahead and finish this. And then we could always go back and reorganize it. Okay, so in this case, for this guy, it goes into the base, right? Signal goes into the base, which the signal is coming off of. Oh, and this is for the speed controller, by the way. Signal is coming off of PS6, which is GPIO 0. GPIO 0 going to the base. Then the base is also going to the negative side of this guy. So the base is also going into the negative side of this guy. And then that's going into the negative side of that guy pretty much. Okay. And then the signal for the servo just comes out straight out of the PS7, which is GPIO 2. GPIO 2 straight to the signal pin. Oops. Didn't want to do that. Straight to the signal pin. And then these are going to be the different colored ones. So let's say this is, what do I have? I know I have blue and brown. Let's keep it consistent with what the servo actually is. So this is blue, and then let's make this guy brown. Brown. Okay, and then let's go ahead and wire this guy up, and then we'll call it quits because we're at 37 minutes already. Okay. Motor plus, motor minus. So in this case we're following this guy, so the 5 volts, I think this is going on this side though, so it should be this plus and this minus coming out, so it should be plus plus going into the this side, which is current collector IC, and then the emitter. Here it's saying 0 volts at the emitter. So again, one last time, coming in through the collector. So positive coming in through the collector. I believe this is right. I'll figure it out eventually. And then black, which is basically where it comes out, is out of the emitter. The emitter is going up to the red of this guy, which those are both red, and then this guy comes back through down to this guy. It's black. Alright, so that should be it. We will do double check after in the next video. So that's pretty much it for this video, guys. I'll see you guys next one. This is Steve with LegitTechTutorials. Thank you guys for watching. If you like this video, please subscribe for more videos like in this series or series as well. I'll see you guys next video. Thanks for watching. Take it easy. Peace.